Okay, folks, so today we are going to be doing mole mass problems. So we're continuing in stoichiometry, and we're going to be converting from moles to mass and mass to moles. Okay, so you're going to need 5 things. So we're going to need pages 6 and 7 from the Google Classroom or your packet. You're going to need your calculator. You're going to need a periodic table. You're going to need paper, and you're going to need a pencil. So if you want to pause the video right here and go fetch these 5 things so that you will be prepared to work problems. So what we're going to do is, I think the best way to learn these problems is just to dive right on in. So we're going to be looking at page 6 from your packet. It looks like this: worksheet mole mass problems. And what we're going to do is we're going to work through this together and talk a little bit about what you're doing. And then for homework, you're going to finish this page, page 7 on the back, and then you're going to complete pages 8 and 9. And this is a mixed review. So you're going to have some mole to mole, like our last problems, and then you're going to have some mole to mass, like we're doing today. So let's start with number 1, and we'll work through. You'll notice that it's several parts, and so we're going to go from there, and then I'll turn you loose and let you work on number 2 on your own. So number 1 tells us that in a reaction between the elements aluminum and chlorine, aluminum chloride is produced. And then very nicely they've written out the base equation for us. The only thing they haven't done is balance the equation, because I have 1 aluminum, but I have 2 chlorines and 3 chlorines on this side. So I know that I need to go and put a 2 here, and that makes it 6 chlorines. So I need to put a 3 here. And so I have 1 aluminum and 2 aluminums, so I need to put a 2 here. So 2 aluminums, 2 aluminums, 6 chlorines, and 6 chlorines. So now it's a balanced chemical reaction. So let's look at A. So A tells us 2 moles of aluminum will react with how many moles of chlorine? Well, if this is the 2 moles, we know that this is going to be 3 moles of chlorine, because we know that the coefficient tells us that, to produce how many moles of aluminum chloride? So how many moles of aluminum chloride? 2. Very good. So now we can move on to part B. So part B is a problem. It's asking us how many grams of aluminum chloride will be produced if 2.50 moles of aluminum react. So what I'm going to do is I'm going to rewrite my chemical equation just so that way I can get to it a little easier. So we have 2 aluminum plus 3 chlorine yields 2 aluminum chloride. And just like we did before, I'm going to look at what's given and what is unknown. So they're wanting me to find grams of aluminum chloride. So right above aluminum chloride, I'm going to put question mark grams. So that way I know that this is what my target is. And then they're telling me that I have 2.50 moles of aluminum. So right above my aluminum, I'm going to put 2.50 moles. Okay, so we learned in the last problem that if they give us a quantity of 1 part of the equation, we can use the mole to mole ratio to bridge the gap to the other one. So I'm going to start with my given, which is 2.50 moles of aluminum. And then I want to get to moles of aluminum chloride. So to do that, I'm going to put my 2 moles of aluminum on bottom. I'm going to put my 2 moles of aluminum chloride on top. And now that leaves me with moles of aluminum chloride. So I've bridged the gap. I've been able to leave this and move over here to work towards grams. So I have moles of aluminum chloride, and we know to convert moles to grams, we're going to use molar mass. So I need to know the molar mass of aluminum chloride. So I have 1 aluminum, 1 times, 3 chlorines, 3 times. So using my periodic table, I see aluminum is 26.98 grams per mole. And I know chlorine is 35.45 grams per mole. So I'm going to work those out over here. And now that we know how to do this, we don't necessarily have to write everything down. 26.98 plus 3 times 35.45. And I get 133.33 grams per mole. And I'm going to double check that just to make sure. Yep, and that's correct. So now I can put this in to get grams and get rid of moles. So that means I'm going to put my 1 mole of aluminum chloride on bottom, and I'm going to put my 133.33 grams of aluminum chloride on top. And now I just work it out. So I'm going to say 2.50 times 2 times 133.33 equals, divided by 2, divided by 1, and I get 333.325 grams of aluminum chloride. And I'm going to double check just to make sure, because I would rather run it through one more time and get it right than not and get it wrong. So now I have 333.325 grams of aluminum chloride, and I have to go get sig figs. So how many sig figs were in our given? 1, 2, 3, because that's the final zero after the decimal. So that means I need to do 1, 2, 3. And of course, 3 does not round that up. So my answer is 333 grams of aluminum chloride. And I'm going to circle that. So that's my answer. So just to kind of break this down, this is what we did in our last problem set. We are literally just taking it one step further by adding in molar mass of the unknown, okay? So the mole to mole ratio allows us to bridge the gap between one substance and another substance. Okay, so this is our bridge in between everything. So let's go look at C. So C says how many moles of Cl2 must react to produce 12.3 grams of aluminum chloride? And you're going to see me write back down my chemical equation because I like to write my known and my unknown up there so that I can see it. So I'm going to put my 12.3 grams of aluminum chloride above it. And then they want to know moles of Cl2. So I'm going to put a little question mark mole. Okay. So I'm going to start with my given. I'm going to write it down so I can see what I need to do. So they're giving me grams of aluminum chloride. And I need to get to chlorine. So the only way I can go from aluminum chloride to chlorine is to use the mole to mole ratio. But in order to use it, I've got to get grams into moles. So to do that, I'm just going to find my molar mass. And luckily, we've already done that. Right here, we found the molar mass of aluminum chloride. So I'm going to come in here. I'm going to put my 133.33 grams of aluminum chloride on bottom, and my 1 mole of aluminum chloride on top. And now that leaves me with moles of aluminum chloride. So now if I want to get to moles of chlorine, what do I need to use? My mole to mole ratio. So 2 moles of aluminum chloride on bottom and 3 moles of chlorine on top. This is going to cancel out. And now I just work it out. 12.3 times 1 times 3 equals, divided by 133.33 equals, divided by 2 equals. And I get 0.138378459 moles of chlorine. And of course, I'm going to run that through my calculator again, because I would rather take the second to do it than not and miss it. And that's correct. So sig figs, 1, 2, 3 are both significant. So I'm going to say 1, 2, 3. And of course, 3 does not round it up. So my answer is 0.138 moles of chlorine. And that's my answer. Okay, so now what I want you to do is we're going to do D, but the way we're going to do this is I want you to pause the video when I say 3, 2, 1, pause, and I want you to work out D, and then after you've worked it out, I want you to watch me work it out. Let's see if you did it correctly, okay? So 3, 2, 1, pause. So I'm going to come down here and, of course, write my equation one more time. Okay, so this time they tell me I have 3.4 moles of chlorine. So I'm going to put that right here, 3.4 moles. And they want to know grams of aluminum. So I'm going to put my question mark grams. So I start with my given. And I need to get to aluminum. So to do that, I'm going to use my mole to mole ratio. So I'm going to put my 3 moles of chlorine on the bottom. I'm going to put my 2 moles of aluminum on the top. That cancels out. And I'm not finished though, because they want me to find grams. So to do that, I'm going to put in my molar mass of aluminum, which will just be 1 mole of aluminum. And on top, it will be 26.98 grams of aluminum. And then I just run it through my calculator. 3.4 times 2 times 26.98 equals, divided by 3, divided by 1, and that is 61.1546667 grams of aluminum. And of course, I'm going to run it through one more time just to be sure. And that's correct. And I have 2 sig figs. So 1, 2. And of course, 1 does not round it up. So my answer is 61 grams of aluminum. Okay. So if you got 61 grams of aluminum, bravo. If you didn't, try to see where you got a little mixed up. So now let's go on and do the last one here, E. And we'll do the same thing. When I say 3, 2, 1, pause, you pause it and try to work it out, and then we'll check yourself, okay? So 3, 2, 1, pause. So once again, we have 2 aluminum plus 3 Cl2 yields 2 AlCl3. So they tell us 17 grams of aluminum react, and they want to know how many moles. So I'm going to come down here and I'm going to put 17 grams of aluminum. And I need to get from here to here, but to do that, I've got to have a mole. I've got to convert to moles. So I'm going to do my molar mass first. So that's 26.98 grams of aluminum and 1 mole of aluminum. So now I can do my molar mass. 2 moles aluminum chloride on top. So that cancels out. So I'm left with moles of aluminum chloride, which is what I'm looking for. So now I run it through my calculator. 17 times 2 equals, divided by 26.98 equals, divided by 2. And I get 0.630096368 moles. We'll do it one more time. 17 times 2 divided by 26.98 equals, divided by 2. And I get that. So now 2 sig figs, 1, 2. 0, of course, does not round it up, so 0.63 moles of aluminum chloride would be my answer. Okay, so let's just kind of recap what we've learned. So if it is a mole to mole problem, you just do your given and then the mole ratio. Okay. If it is a mole mass problem, if your given is in moles, you're going to use your mole ratio and then the molar mass of your unknown. Okay. If it is a mass to mole problem, your given will be in grams. So you do your molar mass of the given, and then you do the mole ratio. Okay? So that just kind of gives you a skeleton of how to work these out. Okay? So you're going to complete page 7 in your packet. And page 7 is just one more problem, just like what we did. Then when you get finished, you're going to flip it on over to page 8 and 9. 8 and 9 is a good mixture. So when you're working these, it's very important that you do like I've been doing. You'll notice that every time I write out my equation, I write my given and I write my unknown. Don't cheat yourself by cutting corners because you're more likely to make mistakes when you cut corners. Okay? So if you have any questions, feel free to email or text me, and I'll look forward to seeing your work.